information to start. When you have stuff that you're given with specific stuff to start, you also usually have some form of a diagram, which means you have to draw the diagram and you have to actually use the diagram to your benefit. Okay? So take a second, write this out, draw the picture, and I want to make sure you guys see exactly what's happening, because today, over the next few days, we're basically adding an extra step to what we've been working on. Now, when you're given information, I have perpendicular. That means I look on my sheet. That means you read your sheet and it tells you exactly what to do. Okay? Which, like, come on guys, write this, draw the picture. It tells you those two are perpendicular, so you write that down. The reason I wrote that down, because it was given. According to your progression sheet then, as you read through it, the very next thing it says on your sheet, or it should say, it says, state the right angles that are formed. It doesn't say to do anything else, it just says, state the angles that are the right angles that are formed, which means, what are the two right angles in this case that are created? Well, you have angle ABC and angle DBC. Those are the two right angles that are formed, and notice I marked my diagram with the information that I know. Angle ABC and angle DBC are right angles. Did I do anything else? Did I say that they were congruent? Did I say that they equaled 90? No. All I did was wrote down that they are right angles, because you know why? My sheet told me to. The reason, definition of perpendicular. I go back to the next step that's on my sheet. It tells me, state that the right angles are congruent. I have the angles there. I'm going to write down now that angles ABC is congruent to angle DBC. All right angles congruent. There was nothing out of that information that you had to come up with on your own. Everything that was in that information is on that sheet of paper for you. If you don't have that written down, you're just doing yourself a giant disservice. There's nothing else that I can do about that. There's nothing else that I can make up out of thin air about it. I'm not changing my letterings. Notice I'm putting angle symbols in front of stuff. You have to, because that's what we always do. Okay? And I go on to my next part. The next part says that segment BC, or ray BC in this case, doesn't matter, is an angle bisector of C. So we write down BC bisects, or angle bisector, I'll use the symbol, of angle C. That's given.
What does that do to your angles, you guys, if you have a bisector?
Yeah.
So you just say that. You want to mark it and you want to say it.
Exactly. Exactly. So when we have that information given to us, actually, according to your sheet, it specifically states if you're given an angle bisector, if given an angle bisector, then angle congruent to angle. Okay. I just figured out what are the angles. Well, how many letters do you have to have for angles? 3 of them. If it's bisecting angle C, that means the vertex of these two new angles have to be where? At C. They have to be there. You guys were taking one of the quiz questions on the proofs there, had an angle bisector, and you were writing down the wrong angles. And the reason that was happening is because you weren't looking at the diagram. Most of you guys were getting stuff wrong on the quiz because you didn't mark the diagram. You didn't know where your lettering was going. So you had a lot of letterings backwards, or the wrong ones completely, or you're making stuff up because you weren't trying to look at the sheet. Yeah, everything's in. Yeah. Like I said, I have a handful of kids that were gone in the other classes, so I wanted to get those graded for, give them to them today, and then I'll get everything back tomorrow. Because we have a lot of going over stuff. So now we know that these two angles in here have to be the same. So we write down with how many letters do we need, and a symbol. Angle A. You got to remember ACB is congruent to angle DCB. What's that? And then the reason is definition of an angle bisector. Now, some of you guys, there was one of the givens on the quiz was this: put away your phone right now. Don't worry about it. You don't need to worry about it right now. The given statement, I believe, was a segment bisector, correct? Most of you guys said it was an angle. Because you didn't read, it was a segment. So you kind of, again, things were getting made up because you weren't reading cautiously or carefully. Okay. Now, right now in this diagram, we've got two angles together, which means I have to find a side after it or a side between them. What can we get? Yes, sir. And what's the reason? Perfect. In this case here, since you've got your two angles, you'd either have to find a side after one of them, either way, or a side between them to make it work. Because I'm looking at my lower corner, I think most of you guys have in the lower right, for the possible ways. So you're looking at your diagram, looking at this. What is it matching up with? What are the things that are trying to get it to look like? So that's what you're referencing to figure out what else you need to come up with. So in this case, in this instance, all you had to come up with was one step on your own, that BC, congruent to BC, and like Morgan said, it's because it's the reflexive property. It's not shared side. I know that's what we wrote on there, look for a shared side, but the rationale behind it, the reason behind it working is because of the reflexive property. That's what we're using. Okay. Now, do you have two triangles congruent? Yeah. And the reason was angle side angle. Yeah, we're going to get there. It's not that we're not making things up. We're not changing letters. We're taking the diagram and filling it through. Okay. Right out. Oh, I'm sorry. Did I go too fast on that one? You guys finish that up? Sorry, that's an awfully really bad.
More examples, you have everything else of how to do the proofs, so that I don't understand. So I know you write these down in the notes. So it's like a sign
Bless you. All right. We just did one with the bisector on it. You should be able to follow. So again, first thing you do, first given, AB, congruent, CB. What do you do to the diagram? You have to mark it. You have to get in the habit of drawing the pictures and marking it up. I know that when we were doing the proofs and stuff like that, you guys had handed in over the past week or so. They're not even drawing the pictures. We can only say it so many times in so many words that you need to draw the pictures in order for yourselves to see where these things progress themselves through. So AB and BC. Next one says that BD bisects the angle ABC. Well, where's the angle ABC? It's up at the top, isn't it? Okay, does it say angle A or angle C? No. Does it say anywhere around angle D? No, it says angle ABC is bisected. That means those two parts. So we write it out. Okay? That means, as I marked my diagram, I know specifically which angles they are. ABD, CBD. Okay. According to my diagram, I've used all of my given stuff, which means I have, as of right now, I have a side and an angle, which means I have to find another side after the angle or another angle after the angle. So we only have side, angle, side, or angle, angle, side, or we can use, I can get an angle prior to it with an angle, side, angle. Is there anywhere in here that I can say anything about angles A and C? No, there's nothing there.
And I noticed a lot of you guys just like make that stuff up. You're like, oh, these two things are perpendicular. Did it say it was perpendicular? Did they give you a symbol for that? Did they tell you angles were congruent? You can't just make stuff up. You have to be able to see it in the diagram.
And a lot of times, some of you guys are just writing down things to fill it in, make it look like you did something. Like midpoint. Oh, look, there's midpoint. No. Midpoint. Correct. And that's where we're getting at. You look to see what's there. And on the progression sheet, one of the hints that we had on here was look for that shared side. And unfortunately, some of you guys are writing down shared side for the reason. Well, that's the hint to look for it, but it isn't the reason here. So you would write down, just like you said, BD congruent to itself. And now, according to your diagram, you have side, angle, side. So you've got your two triangles that are congruent to each other. And today, I want to do one extra step. Now, think about what we've been doing. We've been using, we've been looking and trying to prove triangles being congruent via one of those methods. Side, 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 angle, side, angle, angle, side, angle, side, angle. We mentioned a little bit about hypotenuse leg. It doesn't show up all that often. We'll probably get more of that later on this week. But what happens here then is now, once you have triangles that are congruent or congruent figures, that means that all the parts wind up being congruent. Right? When you have all parts being congruent, that means all their corresponding parts are congruent. So what we can do now is say that angle A is congruent to angle C. Now you can say it, because once you have triangles that are congruent, you can say what's called all the, and this is our new thing for today, corresponding parts of congruent. Yeah, I'm showing you what this is. Yeah, I'll get there. when we first talked about the idea of triangles or shapes or anything, we always had to say that all of the corresponding parts needed to be congruent to show that things were congruent to each other. Remember in the very first section we had to do all three angles, all three sides, whatever shape it was, we had to do that many angles, that many sides. Well, what happened then is that we only had to show certain things, side, 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 angle, side, and so on. Well, it works going both directions. You can show just those little bits like we've been doing, and then therefore what happens is once you have triangles that are congruent, then all of their corresponding parts are congruent. And that goes back to the lettering. Remember how we talked about lettering? If we had a triangle ABC was congruent to triangle XYZ, we knew that, yeah, angle A would have to be congruent to angle X, B, Y, C, Z. Yeah, exactly. I don't know if you guys can hear Josh, but what he's saying is that the lettering matches. AB goes to XY and so on. There was that direct correspondence. Well, what happens now is that once you say that you have triangles that are congruent, you can then say all their corresponding parts are congruent. And that's where this thing comes in. This corresponding parts of congruent triangles are congruent, which stands for, yes ma'am? I would, exactly, cpctc. We don't write this whole thing out all the time. We use what's called corresponding parts of congruent triangles are. No, I was just showing why things match up. Okay. You knew that. This is why it works. The reason that this stuff works is because these two letters match up in the correspondence of the triangle. A and C match themselves out. So they follow that correspondence. There's that direct correspondence between the lettering. Walk, please. Direct correspondence between the lettering. It works. So that's why whenever you're done with triangles, you can then say all of their corresponding parts. Sorry.
I remember that very first lesson we did here, we had it was on the next 2 days, with the X and match up, all the corresponding sides, and all the corresponding angles, things were congruent. All of these things, this SAS, SSS, these are all shortcuts. We didn't have to prove all three angles and all three sides. We can use these shortcuts. But because that is true, then all the corresponding parts of those triangles.
And the cpctc thing, the corresponding parts of congruent triangles congruent, whatever, how you want to set it out so fast. That shows after you have triangles that are congruent, you can say that. Yeah, Quinn.
Pretty much
Yes, sir. Exactly. Because those two parts correspond to each other. The last ones that we have then was AD, you were saying, and then CD. That's another thing that I can say because those parts correspond. That's how all this stuff works itself out. It's the idea that you get your triangles first, which we've been working on, and this is that next step that you finish it. So, it depends on what they ask you for. Sometimes they'll ask you for one part, sometimes they'll ask you for something else. We'll do another example here. Get one up here real quick. So this is the kind of the idea here. You'll be given stuff, and instead of having to prove that you have triangles are congruent, you'll be having to prove parts of triangles are congruent. The lettering and all that still leads you to one of the methods to show it. You use your given statements like you would, whether they're segments parts, or they're angle parts, or the midpoints, or whatever. It always depends upon what you start with. You bounce it off your progression sheet to help you find your way through it and go from there. So let's write this one out, okay? This is we've done one very similar to this a couple of occasions, actually.
That one's very similar to that one.
I think that one had a parallel lines. But if we're looking at this one, I think only this is one part, aren't we? Yeah. You know what? So we write out our given. AB is congruent to EB. What? I'm sorry, what's that? Uh-huh. I don't know where you're getting at. Uh-huh. Yeah. Oh, I see what you're saying. You're just trying to follow the letters out. Okay. I know where you're going with it, but I wouldn't worry about that until you have triangles. Get the triangles first. Okay. So we do this. We have your given. It already was marked up for us to start. Nothing I can do about it. Angle D is congruent to angle C. That's also good. Now, in terms of what you have in the triangles right now, you have an angle and a side. You have an angle, but the side isn't next to it at all, so that means you have to get another part to it. What's up? Oh, thank you. Yeah. Sorry, I didn't realize I wrote that. I was looking at the angle D, or I think Josh had said D when he was talking about it when I was writing it out. Thank you. Yeah, Quinn? Not vertex angle, vertical. Vertical angles. So, again, on your diagram, or in your progression sheet, one of the things was to look for vertical angles. Okay. Now, in that example, some of you guys were being very literal about what we wrote out for our example. We had a 1 and a 2, so we didn't have to worry about lettering. You can't just make up all that angle 1 and a 2. You have to use the letters. So in our case, we have angle A, B, D is congruent to. Well, this is where you have to be very careful about how your lettering is, because we have to show that the triangles are congruent. We have to know the right direction. Quinn, you said A, B, D, and then C, B, E. I want you to change that. You started with no tick mark through here, ended at the angle. Yeah, I'd like you to get to that, because now, by doing it that way, you're getting your angles and your sides to match up via the lettering. Does that make sense, guys? Yeah. So I know that I already have a tick mark at D, which means wherever I put D in this order, C has to be in that spot as well. And our reason vertical angles are congruent. And we wind up with angle side. Now what's nice is that if you look at what we just showed about the angles use how many letters? 3. How many letters do triangles need? 3. Since ABD and EDC match up letter-wise, can't I just reuse those same letters for the triangles? That's the idea. You're trying to get some of the harder stuff out of the way so you can write the triangles out now. Triangle, ABD. And we have angle, angle, side. Now that you have triangles we can group, what can you say about all of the corresponding parts? Exactly. In this case, he wants to talk about DB and CB. So we write it out. DB, root, CB, because of, there we are, corresponding parts, congruent triangles. You're still doing the proofs. You're still doing the same basic scenarios that we have been working on. What changes ever so slightly is that you have that last step. You'll have that last step, and you have to decide what triangles they are. Yes, ma'am. It was given. That was the proof statement that I had. I had it written up. It'll tell you what you have to prove. Okay. And there we go. Actually, okay. Let's talk about parallels. Parallels are still a big issue. When you have parallel lines, the trick was after you draw the picture. And I told you guys to try to make it see parallel. When you do that, where you change direction, those are the angles that point. That's the trick. Here's what I mean. We have our given statement. BA is parallel to CD. Remember, then it's a matter of going to the diagram. There's your parallel. So what you would do is you would make a Z. Where it changes direction, if you look at it, see how this part makes an angle there, and this one makes an angle there? Those are the two that work out to be congruent. So that's how you write it. Use the Z to help you find your alternate interior. So angle BAC is congruent to angle DCA. And you do that. That's how you write out your reason for when you have parallel lines. You have to write it out completely. You have to have that little symbol. And you have to say the right angle correspondence. More often than not, it's going to be alternate interior, especially if you can make a Z. If you can make a Z, it's alternate interior. Then I do it again. Next one. BC AD. BC, AD, where the angles are formed, the little, where it changes direction, those become congruent. It's just a matter of them writing out the letters. It's just kind of tough sometimes when you look at it. If you're having a hard time seeing where I'm going with this, when you're parallel here and here, if you make the Z, when you make the Z where it changes direction, these are the ones that are the same. Okay? Where it changes direction are the ones that are usually the same. That's the trick with that Z thing. Same thing when I went this way, made the Z. Where it changes direction, they're the same. Okay? It's just tough to see because that picture is kind of small. So BCA. DAC. Same reason. You get that? Okay. So now you have two angles. What else can you find? The side. What's the side? What side is it? Yeah. AC or CA, however you want to say it. Okay. CA is congruent to itself. There's your reflexive property. And now you have triangles. There was angle, side, angle, if I'm not mistaken. But this wanted you to prove CD then. So do we have enough information to say that CD is congruent to BA? And the reason? What we're getting at here, guys, is that you wind up having a couple extra steps. You're still using all the same progression, you're still using all the same diagram ideas, you're still filling in blanks. It's just a matter of what's left that you have to show. What I want to do with this real quick is write out, there's a couple of parts on here that I want to give you how to set up. Maybe. Yep. Flip over to the fourth one. Instead of proving that it bisects, I'd like you to prove that it does that. And then on number 5, also do that angle R is congruent to angle W on number 5. That way you're just getting that extra bit of that cpctc thing. Okay. And then we'll do some more of this stuff throughout the week here. My best guess is that between today and tomorrow is that we're working through a lot of this corresponding stuff. With our half day on Thursday, I'm thinking of maybe a 2 to 3 question proof. Because we'll have plenty of time to do 2 or 3 of them. So yeah, with cpctc. Yo. No. So yeah, Thursday because it's conferences. So Thursday we'll plan on like a 2 to 3 question proof quiz again. Going into the conference stuff, it should be a big deal. But it's all going to be basically, it's all the same exact scenario stuff that we've been working on, guys. We just add that extra little step towards the end. Okay. All right. What do you mean? So guys, you got a couple minutes to get started. At least copy down what we did in class on the sheet because you'll notice that we did 2 of them. Yo.